Hello everyone. Now we're gonna solve a hard problem from Calculus 2. So here we're given a function which is x squared over a squared plus y squared over b squared cube, which equals to x to the 4 over h to the 4 plus y to the 4 over k to the 4. So if we graph this function in GeoGebra, we will see a function which is, let me draw a function. Which is symmetric from four sides. So if we solve only one side, at the end we can multiply it by 4 and we will get our final result. So let's consider this part as 1, 2, 3 and 4. And now we will solve this part, which we can call as area 1, and at the end multiply it by 4. So to simplify, we can consider polar coordinates as x equals a r cosine theta and y equals b r sine theta. So when we plug in this x and y into our function, we will get a r cosine theta squared over a squared plus b r sine theta squared over b squared cube, which equals to a r cosine theta to the 4 over h to the 4 plus b r sine theta to the 4 and over k to the 4. We can eliminate a squares and b squares. So we will have r squared cosine squared theta plus r squared sine squared theta cube, which is a to the 4 r to the 4 cosine to the 4 theta over h to the 4 plus b to the 4 r to the 4 sine to the 4 theta over k to the 4. So we have here r to the 6 and here we have r to the 4. So we will have r squared, we will have r squared and r squared yes, we can also consider this cosine square theta and sine square theta as 1. So we will have r square equals a to the 4 over h to the 4 cosine to the 4 theta plus b to the 4 k to the 4 sine to the 4 theta. Our r varies from 0 to square root a to the 4 h to the 4 cosine to the 4 theta plus b to the 4 over k to the 4 sine to the 4 theta. And our degree is from 0 to pi over 2. So we can clear this part to free the space. I'll keep this part. So let's find our lovely Jacobian. In order to find Jacobian, we should find its elements, which are dx over dr, which is a cosine theta, dx over d theta, which is minus ar cosine theta minus ar sine theta, dy over dr, which is b sine theta, and dy over d theta, which is br cosine theta. So we can write our Jacobian here. So dx over dr, dx over d theta, dy over dr, dy over d theta. Let's plug in the expressions. A cosine theta minus ar sine theta, b sine theta, br cosine theta. We should multiply this one by this and this by this. So we'll get ABR cosine squared theta minus, but minus times minus gives plus. ABR sine squared theta. ABR sine squared theta. We know from trigonometry that this one times this one gives 1. So we have ABR. Our Jacobian is ABR. Let's find area. Area, which is A1. So integral from 0 to pi over 2 times integral from 0 to a to the 4 over h to the 4 cosine to the 4 theta plus b to the 4 k to the 4 sine to the 4 theta A B R D R D theta. Let's integrate R. So let's keep AB as it is. The integral from 0 to pi over 2 AB and times r squared over 2 from 0 to a to the 4 over h to the 4 times cosine to the 4 theta plus b to the 4 over k to the 4 sine to the 4 theta d theta. Square root and square eliminate each other, and we can separate this integral into two parts. We can write in the first part this one before plus sign, and in the second part this one. So let me free up the space. So we have a to the 5 b, a to the 5 b over 2 h to the 4 times integral of cosine to the 4 theta plus this part a b to the 5 over 2 k to the 4 times integral from 0 to pi over 2 sine to the 4 theta. So this is our area. Let's now solve cosine to the 4 theta separately and sine to the 4 theta. first let's start from cosine. Let me clear this part. So cosine to the 4 theta equals to 1 plus cosine 2 theta over 2 squared. When we open the brackets, we have 1 square, which is 1, plus 2 times cosine 2 theta plus cosine square 2 theta over 4. We can write cosine square 2 theta as, let me just rewrite it, 1 plus 2 cosine 2 theta plus 1 plus cosine 4 theta over 2, and this is over 4. So we can multiply this one by 2, so we will have common denominator, and when we will have 2 in the denominator, we can flip it up, so it will be 4 times 2, which is 8. So our denominator is 8. So this one, 1 times 2 is 2, plus 1 is 3, plus 4 cosine 2 theta plus cosine 4 theta. Okay. When we put cosine into this expression, we can put 1 over 8 in front of the integral, so we'll have 1 over 8 integral from 0 to pi over 2, 3 plus 4 cosine 2 theta plus cosine 4 theta, and it equals to 3 pi over 16. You can check it. So 3 pi over 16 is our cosine to the 4 theta. Our sine will be sine to the 4 theta will be 1 minus cosine 2 theta over 2 squared, which equals to 1 square, which is 1, minus 2 cosine 2 theta plus cosine square 2 theta over 4. We can write the alternative way, which is this one. So 1 minus 2 cosine 2 theta plus cosine squared 2 theta. No, we can write it as 1 plus cosine 4 theta over 2 and everything over 4. And again we will have when we multiply this expression by 2 in order to get the common denominator, we'll have 2 plus 1, which is 3, minus 4 cosine 2 theta minus 4 cosine 2 theta plus cosine 4 theta over 8. Yes. So when we put it into our integral, we get, again we can write 1 over 8 in front of the integral. So 1 over 8 times integral from 0 to pi over 2 3 minus 4 cosine 2 theta plus cosine 4 theta I forgot to write here d theta, isn't it? Yes, d theta. And again we will have 3 pi over 16. You can check it. So this is our sine to the 4 theta. Alright. Let me clear this part. As you can see, we have common cosine and sine to the 4 theta, which is 3 pi over 16. So we can write 1 3 pi over 16 times this plus this. So 3 pi over 16 times a to the 5 b 2h to the 4 plus a b to the 5 2k to the 4. We have 2 here and 2 here, so we can multiply it by 16, so we'll get 3 pi over 32 times a to the 5b over 2h to the 4 plus ab to the 5, 2k to the 4. So this is our A1, and as we said, we have four similar areas, which is our main area A. So we will just multiply this expression by 4. So 4 times 3 pi over 32 a to the 5b 2h to the 4 plus ab to the 5 2k to the 4. So our final answer is 3 pi over 8 times a to the 5 times b over 2h to the 4 plus a times b to the 5 over 2k to the 4. We did it. This is our final answer. Thank you for listening till the end. Have a nice day.